Hello everyone, this is Sakshi and I welcome you all to my edutech platform Way to Learn. So today I'm going to solve some of the problems from mathematical physics and it's again from complex analysis and its counter integration. So yesterday I had a video on the counter integration of type 1 which had closed intervals and was dependent on the function z. Here you have an interval from 0 to 2 pi and it is dependent on theta. So how do we solve such kind of problems? So first assumption is to consider the contour to be a circle centered at the origin with unit radius. So we do this because we don't have anything given on like any information given on our contour. If we are going to change this to a closed contour, we need to have some information about our contour. So we are going to assume this to be a circle centered at the origin with unit radius. So step 2 is to assume z is equal to e power I theta and dz will be d theta will be dz by iz. So so the next thing we have to do is substitute d theta is equal to dz by iz, and then we have to replace cos theta by 1 by 2 z plus 1 by z and sin theta as 1 by 2y z minus 1 by z. So these replacements are to be done only in the denominator because in all the previous problems they have not asked any questions uh, which are given which have cos theta and sin theta in the numerator. But if in case you have cos theta and sin theta in your numerator, you can use this, but it is not that much recommended. But you can try with this. And then step 4 is to change the limit from 0 to 2 pi to closed interval. And then step 5 is the same to find the singular points and the residue. And step 6 is to use the Cauchy residue theorem, which is I is equal to 2 pi I summation r, where summation r is the sum of residues. Now, these are some of the important formulas which you can just directly get the answer for these kind of questions. That is, this is one form where the interval is from 0 to 2 pi d theta by a plus b cos theta, which is equal to 2 pi by root over a square minus b square. So you don't have to solve step by step, substitute for d theta, cos theta, change the intervals, all that. You can directly use this form. So these are four, I have given you four forms which will be very much helpful for you to solve the exams problem. Okay, so this is form 2. Here sin theta and cos theta have the same formula. So even if you put cos theta or sin theta, you're going to get the same answer. And this is form 3 and this is form 4. Now in your form 4, you can find cos 2 theta in your numerator. So here I know that my cos theta, okay, I can write e power I theta as cos theta plus I sin theta, and my cos theta is the real part of e power I theta. So I can write instead of cos theta as real part of e power I theta. That is, in your answer, if you are having any imaginary term, you're not going to consider that. You're going to consider only the real part. So here I told that let us assume z is equal to e power I theta in my step 2. So instead of cos theta, I'm going to write the real part of z. That is, in the answer, I'm going to consider only z. Similarly, for e power 2 I theta, I can write cos 2 theta plus I sin 2 theta. And cos 2 theta will be the real part of e power 2 I theta, that is z squared. So I hope you get this. Let us see our problem. That is, you can directly use the formula that I have given already. That is 2 pi by root over a square minus b square. But I'm going to show you how to solve this step by step. So we have to replace all these like d theta by dz by iz and cos theta by 1 by 2 z plus 1 by z and the interval 0 to 2 pi to closed contour. So next step is to use like you're going to substitute all these in over here in your question, and then you get such kind of thing. That is, these are the following steps. And then later you get that 1 by I dz by 2z square plus fz, 5z plus 2. Now, this is a quadratic equation. So, in order to get my z, I can just simplify the roots, right? So, I get 1 by I dz by 2z plus 1, z plus 2. And then on doing that, I get f of z is equal to 1 by I, 1 by, this is my function, which is 1 by I into 1 by 2z plus 1, z plus 2. So now I can find the poles, that is z is equal to minus half and z is equal to minus 2. Now I know that it is a unit circle. So z will be is equal to minus half alone lies inside the circle, whereas z is equal to minus 2 will be outside the circle. So it is a simple pole, and I am going to find the residue for z is equal to minus half. So on doing that, I get the following steps, and on substituting z is equal to minus half, I get my answer to be 1 by 3i. So this is my residue. My last step is to use the Cauchy residue theorem, that is 2 pi I into summation r. So on doing that, I get the answer to be 2 pi by 3. So if you check by using that form, you're going to get the same answer. Okay, so now if you understand this, then this is your homework problem where you have to substitute cos theta as e power 2 I theta, and e power 2 I theta will be written as z square. That is the one substitution in your numerator. So just try this and let me know the answer. Okay, now let us see our previous homework solution where this was the homework, and this is from the closed interval, that is closed counter, and now we have to solve this. So here we know that 2z minus 5, here there is center is 0 0, that is origin, and the radius is given as 5 by 2. So radius is 2.5, right? So now we are going to draw the circle with radius 2.5 and the center is origin. So you get this, and then we have this function. This is a quadratic equation. Again, I'm going to simplify this and find the roots, that is find the values of z, which is z is equal to 3 and z is equal to 2. Only z is equal to 2 lies inside the circle, that is of radius 2.5. So I'm going to find the residue for z is equal to 2, and it is a simple pole, so I'm going to use the simple 4 formula. So on doing that, I get my residue to be minus 8. So I know that to use the Cauchy residue theorem, which is 2 pi I into residue. So 2 pi I into minus 8 will give me minus 16 pi I, which is option A. So I hope you understand this. So learn this complex analysis counter integration part. It is going to be very much helpful for your exams, and these types of questions are expected in your CSIR exams. So I hope you like this video. So thank you. Like my video, share my video, subscribe my channel, and do not forget to hit the bell. So only when you hit the bell, you're going to get the notifications of my video. So thank you. See you tomorrow. Ta-da!